Okay, everyone. I'd like to welcome you to another edition of Tennessee Turf Tuesdays. I'm one of your hosts, Dr. Jim Brosnan with the University of Tennessee. This is our fourth year of doing Turf Tuesday sessions, and we got another great episode here. We're going to cover a lot of ground related to diseases of warm and cool season turf, particularly dollar spot. Whenever you get a bunch of pathologists in a room, though, you never know what you might talk about. So we could go other places. Before we jump into that, I know everybody who attends these is very interested in pesticide credits and pesticide recertification. All of the information that's needed for that, you submitted at registration. So when you registered for today, you indicated that you either did or did not want pesticide registration credits. And for those of you who said that you did, you indicated the state that you wanted pesticide registration, as well as your licensing number. And that is all you need to get the credits associated with this session. Zoom will create a roster when we're done of individuals who stay with us for the hour. And that is the roster that will go to your state agency to get you the points that you are so desiring. For those that are golf course superintendents that are with us today, at the end of our session, I will provide you all of the information that GCSAA requires for their continuing education platform specific for golf course superintendents. This has nothing to do with pesticides or pesticide credits. It's only for those who are in the golf course superintendent profession. And then last but not least, I'm sure that we'll have questions. We have one of our graduate students here with us today, Mr. Dylan McCallum. He's going to help us steward questions as we go. There is a Q&A box excuse me, at the bottom of your screen. And we ask that you type all of your questions into that Q&A box. Just helps us stay organized. We'll do our best in order to answer any of those questions live and on the air. If for some reason we can't get to one, we can type those responses there and everything will remain threaded. I think that about covers it for now. As I mentioned, today's session is going to focus on diseases. We have my colleague, Dr. Brandon Horvath, with us, and a special guest, maybe our first repeat guest on Turf Tuesdays, Dr. Paul Koch from the University of Wisconsin. How are you, Paul?
I'm doing good. It's good to be back. Good to be possibly the first repeat offender on Tennessee Turf Tuesdays. Thanks for having me, guys.
We appreciate you being here. And, I told you before we clicked play, I'm going to steal a question from Succession Finale podcast. I'm sure those listening are familiar. And I'm going to frame it in the area of dollar spot. So here's my question to start our discussion today. I'm sure Dr. Horvath will chime in as well. Is dollar spot on the Mount Rushmore of turfgrass diseases? I'm going to hang up and listen.
That's an easy one, right? I mean, every part of the country is going to have a different Mount Rushmore, but I'll give you my four for us here in the Upper Midwest, right? Dollar spot, is not only on the Mount Rushmore, it's probably the king, at least as far as money spent and fungicide sprayed. Dollar spot's the king. So my Mount Rushmore for turf diseases, the top three are easy. It's going to be dollar spot, snow mold, and anthracnose. And for that fourth one, that's kind of a bit of a jiggler. I could go with maybe 10 years ago, I might say probably take-all patch or summer patch. Maybe now I'd lean a little bit more towards like a Pythium root rot or something. I mean, it's a disease that we're seeing more and more of. Even up by us, we don't get as consistently down as you guys further south get it, but certainly it's a disease of increasing importance. So for me, those top three are pretty easy ones, and then that fourth one, a bit of a floater, but something on the roots certainly.
So, Dr. Horvath, to go catch me if you can style, do you concur?
I concur. I would say that for our region, our Mount Rushmore is probably dollar spot, Pythium root rot, and then of course being in the transition zone, I would probably lean towards a couple of Bermuda grass and warm season diseases like large patch and either mini ring or take all root rot on Bermuda grass. So we've got a pretty good stable of diseases in the transition zone that we're never short of disease pressure. Although we don't often, Paul, get plots like the overhead shot that you had of your snow mold plots where you can see 98s and 99s for percent disease severity. We don't see that all that often unless it's really bad.
Yeah, snow mold can be bad up here, and it was a bad year for snow mold. Depending on where you were. Southern Great Lakes, there was very little actually, kind of Chicago, Milwaukee, Detroit, over to the Northeast, very little snow mold, but Northern Great Lakes, ton of snow mold, Rocky Mountain West, ton of snow mold, and a lot of breakthrough on treated areas. And we had a lot of discussions about why that was. And I think a lot of it is because we had some early winter rainfall events after those fungicides were applied. And, I always think it's a little unfair, our expectations of snow mold fungicides up here. We apply it and we're happy if we get 21 days of control for dollar spot. And then we're all pissed off if we don't get 6 months of control for our snow mold products. But it was just one of those years that we had some early winter rainfall events, ton of snow kind of late winter, early spring in March. They got like 45, 60 or 50 inches of snow in Marquette in March alone, just way more than normal. So just early rains, ton of snow late in the winter, early spring, and just a lot of breakthrough on treated areas. So
yeah, we have the same issue with our expectations for fungicides for like something like large patch. It's the same deal, right? Like we expect 2 apps in the fall should hold us through the spring, and maybe just 1 app in the spring, maybe no apps in the spring, depending on your budget. And how come I have 3% disease? It's unacceptable. Right.
Yeah. But I mean, it gets to, same thing, I think probably conversations you're having down there. It gets to the fact that the winters are changing and it's making things more difficult disease wise. Right. And from a snow mold perspective, what would be ideal is if you would spray your product, it would snow like 2 days later, and then that snow would stick for, 4 months, and then it would melt off quickly. But that never happens anymore. We get rainfalls, you get big swings in temperatures. Really has an impact on the turf. We're seeing that turf that's not hardening off really much at all going into snow cover, impacting the persistence of the fungicides that we're applying, impacting the aggressiveness of the pathogens. So 5 years ago, I would have probably thought that snow mold wasn't going to be a real important disease for a lot of the country as the winters continue to warm. But I think we're seeing that it's just making things more unpredictable and more difficult to control with all the swings and weird conditions that we see throughout the winter.
Well, I think it highlights an issue that I think is becoming more and more important, right? And it kind of provides a nice segue to talk a little bit about dollar spot too. A lot of people don't know this. But it really should be the Smith-Kearns Koch model, correct? And I think these variations in temperatures, whether we're talking about snow mold, large patch, any of these other diseases, or we're talking about dollar spot, the variation in temperature and the variation in humidity and environmental conditions really highlights the need that we have for having good, solid, predictive models for these various diseases. And we don't have many of them, but certainly the Smith-Kearns model or the Smith-Kearns Koch model is certainly one that has proven fairly effective at being able to predict when we start to see dollar spot pressure kind of spike, right?
Yeah, no, you're right. And as far as the naming of the model, we didn't want to make it sound like a law firm. So we were happy to have the model stop at Smith and Kearns.
So you could have been a son. It could have been Smith-Kearns and Son.
Well, I am so much younger than Jim and Damon, so I'll tell them.
And better looking too.
But you're right. We don't have a lot of really good models, and we need more effective models. And that's, there's a couple of reasons for that. One, models are hard to do and they take forever. The dollar spot model took us 10 years because you collect data for a couple of years initially to develop the initial model. Then you have to validate it in the field for, 2 to 4 years, depending on the data that you get back. And then you have to kind of adjust the model and validate it again. So really, it takes a long time to get a model that works. And, we worked with you on the initial development and validation of the original model and other collaborators at universities around the country. So it takes time to do those models. We're working on snow mold predictive models right now, 2 of them. in my program in collaboration with Dr. Mingyi Chow, who was part of my program, and now he's the new turfgrass pathologist at Rutgers. So we're working with Mingyi on some of these snow mold models, 2 different models actually, one for predicting kind of when your optimal fungicide timing would be for more of a traditional like Midwest long snow cover duration model. And then the other model is more for other areas that don't have prolonged snow cover, but just have cool, wet conditions during the winter. So a model that you might use down in Tennessee, a Rhizoctonia model that would be used out in the Pacific Northwest, down in your area, a lot throughout Europe, just to kind of very similar to the dollar spot model throughout the winter. When are we seeing some of these peaks in pressure? But you need a lot of data. You need a lot of time. We've been working on both of our snowmobile models now for about 7 years. And we've been collecting data for 7 years. And last winter was the first winter that we actually tested the model in the field. So they just take time, but they're important, and they're going to be more important going forward as we need to basically optimize the efficacy of every single fungicide that we put out, right? We don't have a ton more fungicides coming down the pipe. So we need to make sure that we get the biggest bang for every application that we make. And so I think the models will be more needed as we move forward.
Yeah, I mean, and
Yeah,
just
for sure.
segue a little bit into the weed science world. I know this is a pathology discussion, but the same is true. You know, we have emerging resistance issues, not a whole lot of new chemistry coming. And, you know, the questions are more about timing than product selection, one can argue. And your points, Paul, about fluctuating winter temperatures are well taken. I mean, Brandon and I have had some lengthy discussions here, traveling across the state of, you know, as we see warm season grasses that didn't really cold acclimate, get hurt during harsh winter conditions now because of those fluctuations. It begs a lot of questions about cool season turf in this region versus warm season turf, and beyond just putting green surfaces. It's going to be interesting to see how our industry responds maybe to the changing climate that we're presented with. We did have another question while you two were talking. This is a question, I think, for Brandon. Going back to the Mount Rushmore, one of our listeners was curious why brown patch did not make their Mount Rushmore.
That's a good question. I would say Rhizoctonia diseases in general, you could put on the Mount Rushmore, right? So you could throw mini ring, brown patch, large patch all into the Rhizoctonia category and have Rhizoc be on. Maybe it'd be like a 90-degree, you know, like a 90-degree face, and you'd have your Mount Rushmore of those 3 diseases. That's always one of the things that I enjoy in the classroom with the students is getting them to understand that especially in that category with Rhizoc, you've got several diseases that they have to know, and depending on which one you're looking at, kind of, you know, they could be the same organism in some cases, like leaf and sheath blight on bent grass or mini ring on Bermuda grass, same organism, same pathogen, but 2 different diseases, right?
The 90-degree face is such a deep cut pathology humor. I mean, that is wow. Hats off to you, my friend. That is tremendous.
Yeah, happy to take credit for that. We'll add that one. We got to have like the narrowing and maybe like a little cross wall on either side too, just in case.
Getting deeper. It's getting a deeper and deeper cut. Here we go.
Yep, here we go.
If Pat Jones is listening, he's just sitting there going, pathologists are weird, over and over and over again.
Yep, and he would be correct.
So moving forward a little bit here, you know, Paul, one of the things Brandon talked about with brown patch in mind, I don't remember if it was last year or the year before, but, you know, we had a pretty lengthy discussion about the paradigm here historically was not fertilizing cool season grass, particularly tall fescue, in the summer. The old school thinking was that with holding back that nitrogen would make it less susceptible to brown patch, that if you applied nitrogen, you would get more brown patch. And I know there was work that Brandon's lab did, as well as Dr. Kern's lab over at NC State, that kind of shows the contrary is true, that like if you can feed the grass, it's going to grow out of the symptoms more swiftly, and the overall kind of aesthetic hit will be less. How's that relate to dollar spot? I know I've seen you present some pretty interesting things with dollar spot and nitrogen. and the concept of growing out, or maybe say dollar spot being a low nitrogen disease. Can you kind of elaborate a little bit on how those two interplay, knowing we've got lots of lawn care folks listening to us where nitrogen fertility is a big part of what they do?
Sure. So, few years ago, we started up a project. Ron Townsend was a master's student in my lab at the time. He worked for the Chicago District Golf Association. He just took a job as the Western technical representative for Syngenta. And Ron's project was basically to kind of reinvestigate this concept of dollar spot as a low nitrogen disease. Because if you look in the literature, I think we could kind of in general, we get these concepts in our head and we think there's a ton of study on it. And then you kind of go back and look and you're like, oh, no, there really isn't. And that was sort of the case with dollar spot. There had been quite a bit of research on nitrogen and dollar spot, but not in the sense of how most modern golf course superintendents apply nitrogen. None of the studies, or very few of the studies that had looked at nitrogen impacts on dollar spot, were looking at repeated applications of a foliar urea spray or a foliar fertility spray. And so that's what we wanted to look at, is kind of reinvestigate that, but look at it with applications of a foliar urea spray every 2 weeks. So again, that's not how a lawn care operator in most cases would apply nitrogen, but that's what we looked at with the study. And what we were expecting, and so we tested 0, 1, 2, 4, and 6 pounds of N per 1,000 square feet per year, divided into 10 apps. And so what we were expecting with that study was that with each increasing level of nitrogen, we would see a corresponding decrease in the amount of dollar spot, right? So when you go from 0 to 1 and 1 to 2, you would see less dollar spot as you went up the nitrogen scale. And so we did the study for 3 years in both Madison at our research facility, and then also with Dan Dinelli down at North Shore Country Club, north of Chicago, who has probably more research on his golf course than a lot of universities have in their turf programs. So always love testing with Dan and talking through these things with Dan. What we found very clearly at both sites is that we did not see that stepwise, that dose response. We saw basically very little difference in the level of dollar spot at 0, 1, 2 pounds of nitrogen, slight decrease at 4 pounds of N, and then a massive decrease, almost no dollar spot at 6 pounds of N. Now, I still think that those middle amounts of nitrogen, kind of 1 and 2, will help you recover from dollar spot faster, but it doesn't prevent dollar spot from occurring. And it's really not to get to those really high levels of nitrogen that you see that significant response. Now, every time I present that data, somebody raises their hand and says, well, I'm not going to apply 6 pounds of N. I'm like, that's not the point. I'm not telling you to apply 6 pounds of N. That would be bad, right? For a lot of different reasons. But the point is that maybe there's something about that process of applying 6 pounds of N that we can learn from that can help us control dollar spot without applying 6 pounds of N. And so we kind of looked at some other different things. And one thing we found is that was just when we were starting to do a lot of our microbiome work. And one thing we did is we went back in the third year of that study, the third and final year of that study, and we tested the microbiome from each one of those nitrogen levels. And what we found is that the bacterial communities from each one of those nitrogen levels were basically the same, except for the 6 pounds of N. The 6 pounds of N had a very distinct and very different bacterial community. And so sort of our working hypothesis now, and we're doing some follow-up work on that, is that the reason that 6 pounds of N was so effective at reducing dollar spot is that it selected for a particular bacterial community. And that's something we would expect, right? If you put down a ton of one thing, there's likely one aspect of the microbial community that really likes that. And so they're going to eat a lot of that and they're going to increase in population. And so our hypothesis then is that when we put down so much N, there was a certain part of the community that really liked that N. It really increased in population, and that somehow helps suppress the dollar spot. We have some theories on why it somehow suppressed the dollar spot that is a little really wonky that I can get into if we really want to get into the weeds. But we just think that high level of N really selected for a particular bacterial community that was helped suppress the development of dollar spot. So it's not as simple as, you apply more N, the turf grows more and you grow out of the dollar spot. I think there's more of a microbial component to that. Now, let me just follow up quick before I take a breath here, is that we have done other work and others have done work and shown less dollar spot, at 2 pounds of N versus 0 pounds of N. So, I don't think that there's basically no impact of applying 0, 1, or 2. I think it's better to apply 1 or 2 pounds of N versus no dollar spot, but it's not much. It's modest. You're not going to really have a huge suppression in dollar spot at 2 pounds of N versus 0 pounds of N.
Yeah, for sure. It reminds me a lot, Paul, of the mindset with something like Pythium or brown patch, right? Where more nitrogen equals more disease. And then if you go back and look at the literature where that work was done, it was, 10 pounds of nitrogen per year was advantageous for Pythium development. It's like, well, but nobody's applying that today. We're way down at the bottom end of that scale. And so the relationship that fertility rate has to disease development certainly is going to play a role. And then to your point, the microbial community plays a role. Certainly your environment that you're in, temperature, humidity, et cetera, is going to play a role. PGR use, all of those kinds of things probably all have small, impacts. And that's the thing that I think we don't necessarily have a real good handle on as yet. One of the questions that I was going to ask you when you were talking about the model development stuff is, with the advent and the increasing visibility of AI being present, how much effect do you think AI is going to have on our ability to load a large data set of disease development into a learning model and have it spit out things that say, that when this happens, disease goes up or down or what have you? Do you foresee an impact? Do you have colleagues at Wisconsin that are working on that kind of stuff now?
Oh, sure. Yeah. There's, we've worked with some of our snowmobile models. Ming Yi is an expert modeler. He's worked with some of these algorithms, and I'm not a techie guy, right? Took me a little while to get my computer turned on this morning, and so this is out of my wheelhouse, but I understand the importance of it, and so that's why we work with a lot of other people that know how some of these advancements in technology work, and certainly it's going to have an impact. The things that will still be important and will always be important. One is you still have to have a knowledge of the system, of the biology, right? You can't just have a pure data person that just puts in a bunch of data and we kind of pop something out. We experienced that a little bit when we had our first iteration of the snowmobile model, is that we provided a great data set. It spit out a model that appeared to fit past developments of disease, but the metrics that it was spitting out weren't practical for us to use as turfgrass managers, right? Because it would tell us with great detail the weather conditions that would lead to 30% disease, but it wouldn't tell us how to prevent the disease from occurring, right? So we don't, I don't give a shit if it's, if you're a superintendent, you don't want 30% disease, right? So the conditions that lead to 30% disease isn't that useful for us. We want to prevent the initial start of disease. So we had to go back and fine tune what we were telling it and what it was spitting out. The other thing with models, right? I've done a lot of work with models. I'm a big believer in models, but you also, as a superintendent or a turfgrass manager, whatever model you're using, the model is a tool. It doesn't replace your experience. So, the other thing that we say is don't be a model robot, right? So if the model says to do something and you look outside and it doesn't make any sense, doesn't make any biological sense with your experience on that site, then don't do it. You don't have to follow the model, and the models are not always right. So like the dollar spot model is a good example. The dollar spot model uses a 5-day moving average of relative humidity and daily average air temperature. If we get, like we had this year in early May, we had a 5-day stretch where it was very warm. It was 80s, overnight lows in the 60s. If it would have been mid-June, if it would have been right now, it would have been great dollar spot weather. But we'd had snow on the ground 10 days earlier. The fungus just hadn't developed enough from the winter to develop then. So if you would have gone out, if you would have seen your model on May 5th and it said to go spray and you would have gone and sprayed, that would have been a total waste of product because the fungus just hadn't had the time to develop. So you got to understand how the models are developed so you can understand how to best use them. And the experience of the turfgrass manager is always going to be paramount. And these other things are tools to help them do their jobs, but they don't replace their knowledge and their experience.
Yeah, that's well said. I mean, I see that with fungicide programs. Everybody wants to know what fungicide program should I follow, right? And my response is always, and the data that we have from running program type trials for years now is that the program that always does best is what we call the superintendent program, which is you look at the weather, you have the options on the shelf of anything you want to spray, and you spray what you think is going to be active, and you make that application for that particular application window. And there's no set program, right?
Mm-hmm.
You understand the biology and you understand the weather conditions, and then make an informed decision about what you want to protect against. And that always does better than if you just follow some script of this date, this date, this date. And the same's true with a model, right? You have to be able to look at the weather and then decide how you're going to apply that information to make a decision.
What I will say, Brandon, I think where AI and improved analysis of really big data sets will help, I think, is in sort of this precision disease management concept. And we've done a little bit of work in this, not much, but what we did is right now, if you're a superintendent or a turfgrass manager and you're using the dollar spot model, you're probably going to spray the entire golf course based on one number, right? You're probably going to have a weather station at the shop, or you're going to use Syngenta Greencast or Greenkeeper, and you're going to have one model number for your location. But we also know that golf courses have a ton of different microclimates. Disease occurs at different rates and at different stages over the golf course. So really, from a biological sense, it makes no sense to spray your entire golf course at one time for the disease, or rarely does it make sense. And so what we've looked into a little bit is can you put weather stations around the golf course? Each one of those calculates its own dollar spot model, and then you spray based on those individual stations. And so USGA gave us a little bit of money a few years back to kind of pilot this concept at our university's golf course here. And they have a very sort of, different nines. The front nine is more of an open oak savanna prairie type style, very few trees. The back nine is through the woods. And we would expect, and we know because we test trials there every once in a while, the back nine has much more dollar spot than the front nine. And so we put some stations out, and sure enough, the front nine, hole 7, is where I had one of the stations, and that was consistently throughout the year about 10 to 15 points higher on the dollar spot model lower than the back nine. And so, the follow-up research then is, how many zones would you need to break up an average golf course into? What is the difference that would lead to different spray intervals, right? I mean, if one spot is 3 points lower than another, we'd spray that differently than another. But I think AI, because that would be a mass amount of data to collect just for a single golf course. And so if you could use AI to help you analyze that data, help you determine which zones that you would break your golf course or your site out into, and then also what are the sprayable, the treatmentable differences for when you would spray. I think that's a significant advancement in how we would treat for not only dollar spot, but certainly other diseases as well, where it just does not make a whole lot of sense to spray 30 acres of fairways if maybe only 5 are going to be susceptible at any given time.
Well, and it also highlights the need for improved application technology, right? Like whether it's, a small spray drone that could fill up with a small amount of material and go out to specific sites and make those applications automatically or autonomously, or it's a sprayer that has a set of cartridges with different materials, so that as the sprayer is going over different pieces of the property, it can apply one thing or another depending on what those diseases are. Those are things that we don't currently have access to, at least not on large scale operations, for sure.
Yeah, no, I would agree that the advancement, I think the science is there, kind of. It's at least suggests that it's certainly an investable topic or an investable scenario that should be successful based on the data we've collected so far. But the advancements in sprayer technology, I think, are there, right? Spraying by drone is something in ag,
coming.
and I've
Sure.
seen pictures online of people spraying, their native areas using drones. So I think it's there. I don't think it's that far off. We just need to have a better idea of when we would spray different parts of the course at different times.
Yeah, right.
Yeah, so Paul, just a quick question to break it down. What if somebody's interested in using this model, how can they go about utilizing it? Like where to find it, and what you need to put in to get your how much dollar spot pressure you have?
Yeah, that's a good question. Probably something I should have led with now that we've talked about it for 30 minutes. So thanks for cutting in there, Dylan. We have sort of an explanation page on the dollar spot model at our webpage, which let me just kind of, I'll just type into the chat if that's okay. Is there a chat that everybody sees?
Yep.
There is a chat. Yeah.
Okay. Let me just, it's a link on our diagnostic lab website. So I'll just, that would be simpler to do. And so let me just, there it is. And so that page explains sort of the background on the model and how it was developed. It links to the scientific paper if you really want to geek out on it. But it also provides links to some self-calculators. We do provide some Excel files on that website if you want to calculate it yourself. There's really no need to, because different groups have taken the model and implemented into their sort of suite of offerings. So one you can go to is the GDD tracker site at Michigan State. And I don't know if that kind of goes all the way down into Tennessee or not, but that's one website you can use for most of the Midwest. Syngenta Greencast, if you go to the Syngenta Dollar Spot Solutions page and type in your zip code, and you can sign up for email alerts that will email you when the dollar spot model is above whatever spray threshold you set. Based on our research and field validation, we recommend 20% as a spray threshold, but that can vary wildly. We've been doing some follow-up research, and I know Rutgers has done some follow-up research. And if you have a more resistant cultivar bent grass, your spray threshold can go from like 20, which is what we use for Pencross. It can go up to like 40 or 50. So it could be a lot higher depending on the cultivar that you have. So Syngenta Greencast is another good one. And then Greenkeeper is another one. So for those, the dollar spot model is available on the free version of Greenkeeper, but you can get a 7-day prediction if you have the paid version of Greenkeeper. So those are probably the top two. I'm sure there's others. I know that, others in Europe have been using the model because dollar spot's becoming a much more severe issue in Europe as their climate changes as well. So those are probably the two top ones that I know of right now. If anybody else has any other ones that they know of or use, please let me know, and we can add it to our dollar spot webpage.
We had
I know
another
the offerings from measure.io also has the dollar spot model in it. And there's probably a few others, but the other thing, and to your point, the work out of Rutgers with the threshold selections, you can also, and I'd love to hear what you think, but you can also kind of empirically find that yourself by looking at those different threshold numbers and then having a location, whether it's on your nursery or a chipping green or something that's a check plot, so that you can kind of see when do you start to see disease development in a conducive environment that would make you, uncomfortable at that much disease and that you need to go apply. I think it has the most applicability and the most impact, certainly up your way with cool season fairways, right? Where, if you could get rid of 2 or 3 sprays, not only do you save a significant amount of money, but you also start to see, a sharp reduction in the amount of product you're using and putting into the environment, which I think is a good thing, right? So, in our area, if you saved a spray on greens, that's great. But if you're spraying something like, a relatively inexpensive fungicide, you're talking about, a $500 or $600, $700 savings. That's not gonna, make everybody, super excited. But if you're saving a couple $1,000 on a large scale application, that's a big deal.
Yeah, no, highly recommended that you figure out what your own threshold is at your golf course, because every golf course is going to be a little bit different. There's just so many, and that's actually one benefit of this model. I think if you compare it to older models from the 80s, they just say spray or don't spray. There's no number to it, right? It's on or off. And because of all the variables that exist from golf course to golf course, it's impossible really to create one number for every single golf course. So basically what we say is you start at 20, but just like you said, Brandon, figure out what your own threshold is. So have a spot, an out of the way area that you know gets dollar spot relatively early, kind of one of your indicator areas, and just don't spray it. And then keep track of the model. And when you start to see dollar spot, back it up, back up the model a couple of numbers, couple of clicks, and that's your spray threshold, right? So if you started to see some dollar spot at at 30, then spray at 25 or something like that. So, but I think that's really important to do, just because of all the variables that go in every single golf course. We can't possibly put all of those into a model. It makes no sense. Be an impossible model to use. So basically, what we've said is here's kind of the sliding scale. You got to kind of do some of the legwork, but I think in the end, it makes a really, really useful tool.
Well, and I got to think too, Paul, that like if the interventions that we're putting down just for general turfgrass management are affecting disease outbreak, like you talked about with nitrogen and in the soil, turning on bacterial communities that may suppress the pathogen, it's got to make that modeling piece even harder, right? Isn't there data with rolling in dollar spot suppression, where if one's rolling, say, bentgrass putting greens, that turns on different systems that suppress dollar spot? Am I remembering that correctly?
Yep, that was work from Michigan State. Paul Giordano did some of that work, and what they clearly found, right? So there's kind of two approaches, right, Brandon? We can kind of do this two ways. Is you can go back and you kind of understand all the biology ahead of time, and then you kind of develop controls based on that. Or you just go try a whole bunch of shit, and then whatever works, then you figure out why it works, like after that. And that's kind of what happened with the rolling, right? This is something rolling been around for a long time, but really wasn't thought of as a disease control concept. But
no, it was almost a serendipitous thing. Nikolai was doing the rolling for maintaining green speed, and then noticed like, hey, this is getting less dollar spot. What's going on there?
Yeah, definitely. And so, so clearly on putting greens, very clearly less dollar spot on putting greens with rolling. Fairways, the data is not quite as strong, but it certainly appears that there's some reduction of dollar spot when you roll fairways. So what's the mechanism for that? It's not a dew removal, right? They tested that where they went out and they removed dew at the same time they were rolling, and the dew removal plots had more. It wasn't just the dew that was removing the dew that was the issue. The dew removal plots had more dollar spot than the rolled plots. So there's some thought that maybe it's the rolling, the equipment going over that is stimulating some stress response in the plants. That's also leading to less dollar spot, a defense response. One thing that I think might be the most likely is that in the top. The top half inch, they realized that the volumetric water content was higher. So there might have been some light compaction in that top half inch, which is increasing the water holding ability, which might be either stimulating a response in the plant or stimulating a response in the microbial community there right in the top half inch, which could then be suppressing.
Yes, I think there some indication that they didn't do a full microbiome type project, but they did look at some of the microbial community stuff, and it showed that there was some differences there that probably needs more study to really understand. But certainly it could be playing a role, whether it's the volumetric water content or the microbial community that's stimulated by having a bit more moisture there, right?
Yeah, I mean, that seems the most likely explanation based on the data that they've presented in that paper. So I think that makes most sense. And it's not just dollar spot, right? So Oregon State looked at it and found that there was less microdocium patch with regular rollings. So there's clearly a wide scope of benefits with rolling.
Kind of somewhat related, just in that it's a kind of agronomic intervention that relates to the outbreak. We had a question come in about if either of you two could comment on slow release nitrogen versus quick release nitrogen as it relates to dollar spot management. Any one over the other, your thoughts?
Brandon, you want to go first?
Sure, what I would say is that the question about quick release and slow release largely depends on the frequency with which you're willing to apply the material, right? So if you're applying material on a regular basis, every 7 days or every, even, 10 to 14 days, then your source probably doesn't, necessarily depend so much, because you're constantly adding a small amount to even out the growth response. The whole reason why you would use the slow release fertility is to do that same thing without having to constantly reapply. So if you're in a situation where labor is limited and you can't make as frequent an application program as a result of that, then using a slow release source to help smooth out that nitrogen release curve is going to help you. If you're in a lawn care operation where, say, you're managing Kentucky bluegrass and you want a more consistent response from your fertility, then having slow release fertility makes sense there. I don't think it's a question of whether quick release or slow release necessarily makes a difference. It's more about that release pattern and how it relates to the frequency with which you're applying that given amount of fertility.
Yep, I totally agree. I don't think there's anything inherent about quick versus slow release that would really impact dollar spot development. It's really more of making sure that you have that consistent growth. So I totally agree with Brandon there. One thing I want to go back to, which I meant to bring up before.
Can I just interrupt really quick?
Oh, sure,
Paul?
please.
Like one caveat that I would add to that is that when it comes to slow release sources that are coming from some sort of organic material, whether it's a manure base or some sort of organic material, is that there is some indication, we don't have an exact reason or how or why, but that there is some indication that does alter some of that microbial community aspect of it and may play a role as well. So in that regard, if you're using an organic based fertility, then there may be some good reasons to continue to do that. But largely when it comes to the nitrogen piece particularly, it's really a matter of the application rate and the frequency with which you apply it.
Yep. So the thing I was going to go back to, and Brandon talking about the lawn care operators made me think about it, that I meant to mention it earlier. We've never done any research with the dollar spot model on dollar spot and lawns. But I think it's a great situation where the model could be used, because dollar spot's not going to be something that occurs consistently and severely throughout the year on lawns. So the model can help you determine when a preventative application of fungicide might be needed for some of those lawns where they don't want dollar spot to develop. And it's a conversation that I've had more in the past couple of years than I have before, because at least up in our climate, we're seeing more dollar spot develop in lawns than we had before, because our overnight lows, our nights are getting warmer and more humid. And so we're seeing more dollar spot and develop in lawns, to the point where we're getting questions about it. And 10 years ago, nobody cared about dollar spot in lawns. And now we're seeing that more, and some pretty nasty outbreaks actually that we've seen in the past couple of years. So the model, again, we've never done research on it, so I don't know what the threshold would be on when you'd want to spray and when it develops on bluegrass and lawns. Bluegrass is more susceptible to dollar spot than tall fescue would be, but it does occur on tall fescue as well. But I think the model would be a great tool for lawn care operators that deal with lawns that develop dollar spot.
Yeah, sure.
That's awesome. One additional question I had about the model is, does that model, is it consistent across all different types of turf grasses? So if you have a Bermuda grass putting green, is it still very consistent even when you have a bent grass putting green, or does it change at all with the thresholds or anything like that?
Yep. Yes. We developed the 20% number comes from Pencross in Madison. And that 20% number was consistent across Pencross at other sites as well. So, but basically Pencross in the north. in, the Northeast and the Midwest is basically where that 20% number comes from. So if you have any other cultivar, any other grass species, any other dramatically different location, your number could be quite different. So, I mean, I would always recommend before you implement the model to kind of calculate your own threshold. But certainly if you're on a different species or down south or something, you would definitely want to figure out what the threshold would be for your site.
Yeah, for sure. I would say that on Bermuda grass, typically, certainly on fairways, we'll see it pop up, and it's generally a nuisance issue. It's not anything that some fertility won't just take care of. But on putting surfaces where it might be more of a concern, I would suspect that you'd have to alter that threshold to get things to match up more with observation. But for the most part, the model should still hold. It's just a matter of what threshold where you would start to see, like, okay, I'm at increased risk for actually seeing the disease development.
So I'm going to ask another follow-up question, because I've heard you guys talk about this in scientific meetings before, and I think it'd be interesting for the audience to hear it in this forum. So let's pretend, one is planting a new stand of cool season turf from seed. Let's say it's bent grass. They go through all the work to do site prep and renovate. They get a really good cultivar, and they go and they seed, and then they have a dollar spot outbreak. Where did that dollar spot come from?
Well, that's a good
See,
question.
my question was going to be, what is the coolest thing that the end user about dollar spot that the end user doesn't really understand? And I was kind of figuring that you might talk about this, Paul. So take it away.
Sure. So I got my PhD with Dr. Kearns back when he was at Wisconsin, and another person in the lab. Her name is, she's still alive. Her name's Renee Rio, and she got her PhD. And her project was focused on dollar spot. And one of the things that she worked on was testing for dollar spot in bentgrass seed. So she developed a qPCR, a nested qPCR assay, to test for the presence of the dollar spot fungus on and in bentgrass seed. And what she found was that there is dollar spot within bentgrass seed. It's a very small percentage. It was like, of what she tested, I can't remember the exact numbers of seed lots she tested and how many samples from each bag and all that sort of stuff. It was something probably like 0.001% were positive for dollar spot. But if you think of how many seeds are present in a bag of, a 50-pound or a 30-pound pail of bentgrass seed, 0.0001% is still hundreds and hundreds of seeds that are going to be positive for dollar spot. So certainly, I think one of the ways that dollar spot comes in is on infected seed. So, then we've had follow-up discussions. Well, does bentgrass and does turfgrass need sort of a certified disease-free seed situation, right? So something like potatoes, where they plant the tubers, that's really common, right? Wisconsin, big potato producing state, puts a ton of money into producing these certified seed-free potatoes so that there's less disease in the potato fields that year. Would that make sense? Does that make, it would be great to say that the bentgrass seed is certified disease-free. My guess is the amount of work that you would have to do to cleanse all that seed is, the dollar spot's still going to come in some other way, I would imagine, right? So it might come in on a golfer's shoe, or, blow in from a nearby site, or, a mower that's being demoed around or something can bring it in. So, I don't know how much more it would cost for a seed company to have seed be certified disease-free, but probably not insignificant, especially, seed is expensive enough these days. And if the seed is just going to come in, like a year later, or if the disease is going to come in like a year later anyways, I'm not sure that the practicality there, but certainly on the seed is one way that dollar spot comes into a new seeding.
Yeah, for sure. And I guess to pose that same question to me, the thing that I think is most interesting, and it's actually one of the aims of Dylan's master's research, is the impact that ultraviolet light has on the fungus. And we've done a considerable amount of work and are continuing to do work on that I've seen just anecdotally, you were talking about dollar spot being more prevalent in Kentucky bluegrass lawns. I've seen, small plantings of trees in a landscape where in the shadow of that tree, the main shadow pattern, there's more dollar spot than in the main part of the yard where the sun is shining all day. And it's not that the disease doesn't occur in the sunny area, it's that there's less, right? And we've seen the same kind of thing. And, just if you think about it from an evolutionary perspective, if this thing hangs out in the plant and is operating in some way within the plant, then the chloroplasts and the structures inside the plant are going to shield this thing from a lot of ultraviolet radiation. So it makes sense that it's really sensitive to ultraviolet, right? And those are both things I find just extremely fascinating about this organism. And I had no idea when I worked on it for my PhD in the late 90s and early 2000s that it was going to be something I'm still working on in 2023. But it's truly a fascinating fungus for sure.
Yeah, the biology really is very interesting, and it's exciting to see some of the research like Dylan's and others that are helping us explore what the fungus and how it interacts with the plant. Because like you said, it's not like it just gets in and starts rampaging and killing the leaf cells. It kind of delicately like comes inside, kind of lives in there for a while. At least we think it has this sort of latent stage where it just kind of coexists peacefully with the plant, and nothing really that bad happens. And then there's something that switches, and it turns, and it can cause significant damage. And that's why, sometimes you have those overnight outbreaks of dollar spot. It's not like the fungus overnight got inside the leaf, colonized the leaf, and caused those symptoms overnight. It had been inside for a period of time. And then there's some environmental cue or some host cue or fungal cue that caused it to switch and turn pathogenic. So really understanding that process is going to be a large part of really understanding how the infection occurs, and hopefully leading to some more effective strategies for control.
Yeah, for sure. It's just it never ceases to amaze me how it, we think we have it figured out, and then it just, teases us with
To put this in a way that maybe Jim can understand, it's the annual bluegrass of the disease world, Jim.
Well, it's funny you say that, Paul, because I was sitting here, you're talking about low percentages of seed lots having the pathogen present, fractions of 1%. And in the USDA POA project, one of the cool objectives was multiple universities. Tennessee was involved in this. It was led by a gentleman, Andrew Osborne at Texas A&M, who this is the focus of his PhD project there, where we buried seed lots of Poa annua from 10 different locations across the country at different depths in the soil, and we left them buried for different time points. And what we ended up finding was that the viability was really, really low. Like you said, with dollar spot and seed, it was fractions of 1% were viable when they were buried in the soil beyond a year. But when you look at the amount of seed production that can be had from one individual plant, a low percentage of viability still allows for the species to perpetuate their forward. So you're right. It's certainly a parallel.
And to your point, Jim, and to Paul's point, right? Like, it's probably not just in bentgrass. It's probably in annual bluegrass. And so you might go through all that work to get certified disease-free seed, and you get a POA plant that happens to have a little resident dollar spot coming along with it, and off you go, right? It's going to be very difficult to keep that out of a field of a perennial crop, right? Like, very different than an annual potato crop. You've got a perennial crop that you're trying to keep, quote unquote, disease free. It's just not a plausible way to go about things.
Mm-hmm.
Yeah, for sure. Coming to the end of the hour here, what I'm going to do is I'm going to put up our information for superintendents. And while I do that, knowing that both of you gentlemen run lots of different trials for dollar spot control, wondering if you could share anything that has kind of stood out as newer fungicides, different approaches of other fungicides. I know we've talked a lot about the model, but just, I think when we think about dollar spot, a lot of people just kind of think chlorothalonil and then might stop thinking, right? And there's a lot of new and different tools that one can use to go after this pathogen, and was hoping you could share some of your feedback on that.
Sure. What I will say is, so the SDHI class of chemistries has been a very effective class. Longer periods of control, 21, 28 days. The concern that I have, and Brandon, I don't know if you're seeing it down by you, is we are seeing significant resistance to the SDHIs. And I'm not going to pick on the product, but it's one that we've seen a rapid drop in control, and that's exemplar. As recently as 2017, we would get 35 days of control in heavy pressures, and resistance develops so rapidly that we're lucky if we get 10 days with that product now. So the resistance to dollar spot with the SDHIs develops rapidly, and that's a concern, especially on fairways where we want to try and extend those intervals as much as possible. So really, use those judiciously, those SDHIs. They're really effective, but resistances can be pretty severe. And I feel like for a lot of years, we talked about resistance and everybody's like, I don't really care. But now we're seeing some really strong effects with the SDHIs and dollar spot. And I think it's on people's radar a little bit more. So, I've really recommended kind of making, for us on our fairways up here in the Midwest, kind of flazinam as your base product, and then you branch out from there based on what else you need to get. So flazinam, pretty good dollar spot product, normally gets you 14 days of control. The problem is if you don't have the labor or the ability to spray your fairways every 14 days, going beyond that is hard. I think one of the most difficult things for a Midwest superintendent to do from a disease point of view is get 21 days or more of dollar spot control from any product. Doesn't matter what product it is. So that's one thing that we're struggling with.
Yeah, I would say for us, we haven't quite seen the increase in resistance for the SDHIs on dollar spot, but I think that's largely because we're focused on greens for the most part with cool season turf. And so that allows for, but it's coming, right? Like we're going to see it eventually. Certainly the SDHIs were a game changer. The other thing that I think we've seen a little bit of a little bit of a light at the end of the tunnel, if you will, is with some of the newer DMIs and how their binding site affinities are a little bit different than the older, more traditional DMIs. You can see an increase in the interval of control for those. And then certainly some of them are very cost effective as well. So that allows for a lower budget place to get a 14 or a 21 day application out on greens turf that allows them to save a little bit of money that way as well. I think those are the kind of the two big game changers. And then the next piece of the puzzle will be, how do these newer, more dollar spot resistant varieties fare over time? Because, we've seen that kind of first generation come out. Everybody was, kind of excited that could provide the window that they needed on fairways. And that really hasn't been the case. Like over time, you kind of see the resistance of those varieties kind of decline to some level. It doesn't go down to, say, pen cross susceptibility, but it does decline over time. And then, you go from maybe not needing to make applications to needing to make a couple of applications to needing to be on a regular spray program. And then these newer varieties, with some dollar spot resistance, certainly in greens turf would be a really great thing for our region, where if you didn't have to make dollar spot applications, you could get away with something kind of nice that way. But I think those are the things that are kind of hot issues now that we need to further explore and understand better.
Yeah, I agree, Dr. Horvath. Kind of pivoting off of that, where can people go to find out what kind of cultivars are more resistant to dollar spot? What kind of resources can they use if they're potentially regrassing greens or fairways, and are interested in finding a germplasm that's more resistant?
I'd say, from the germplasm side of things. You can certainly check and look at the NTEP trials that are looking at how varieties are performing across the region in which you're in. The new tool that they have is nice to be able to hone in on things like dollar spot resistance versus green color or quality or whatever. So that's a good thing. And then from a fungicide perspective, you know, the two places that I typically send everybody right now are to the PPA1 that Paul, you're a part of, the extension article that has some efficacy data in there, and then turf files. And then of course, Dylan, you know that we're working on some efficacy data that will go into Jim's mobile weed app that will become the mobile pest app for our area, that'll have some efficacy information in there as well. So that's going to be exciting here in the next 6-8 months, hopefully.
One more question before we wrap here, just kind of came in. Any information on, does height of cut make a difference on dollar spot incidence in Bermuda or Georgia?
Paul, you want to handle that?
Well, I don't know about Bermuda or Zoysia. I'll answer on bent grass quickly and then pivot to you, Brandon, for what they actually want. I've never seen any research on height of cut making a big difference with bent grass. From just a biological standpoint, you would think that the higher the height of cut, the more disease you would have, because it's going to hold more humidity in that canopy. But you know, there's a lot of things that are different about, if you know, look at a fairway versus a green situation, that could lead to more disease pressure in fairways and greens. So it might not just be the height of cut.
Yeah, I'd say the same thing with Bermuda and Zoysia. It's not necessarily just height of cut. Although I've seen certainly in Kentucky bluegrass as well as Bermuda and Zoysia at higher heights of cut, dollar spot tends to go from dollar spot to like silver dollar spot, right? Like it's, you know, or silver platter spot, if you will, a little bit larger areas that are the leaf tissues affected. You've got the mycelium growing from leaf to leaf that causes a little bit larger symptom pattern than just a nice, you know, silver dollar size spot. But why that occurs is not necessarily very well understood, apart from just knowing that there's probably a little bit of a microclimate effect, and then more leaf tissue for the fungus to munch on. But height of cut doesn't necessarily, I don't think, you still see dollar spot appear in higher heights of cut. It's just a slightly different symptom pattern.
I'm waiting for one of you pathologists to discover a new disease and call it hubcap spot.
That sounds like a good one to end on there, Jim.
That's a good one to end on. Yeah. Any parting shots before we go? We're coming to the end of the hour. Anything else you want to share with the audience, or everybody hungry and want to break for lunch?
No, nothing else for me. Just appreciate the invite, guys. I always enjoy chatting with you.
Yeah, it's good to see you, Paul. Thanks for coming on.
Yeah, thank you, Paul. I'm sure we could talk dollar spot for the rest of the day, but we'll leave it there. We will be back in July. We'll be delayed. We won't be the first Tuesday of the month because of the 4th of July holiday, but we will be the second Tuesday in July. Our guest will be our new Turfgrass colleague here at UT, Dr. Becky Bowling. So we will see you then. Enjoy the rest of your day.